So, question 5 here is about patterns, and I mean, looking at it here, draw the fourth pattern in the sequence into the box below. So draw the fourth pattern. Now, generally students answer this pretty well, but I just want to remind you here, right, 3 grey boxes, 4 grey boxes, 5 grey boxes, it's going to be 6 grey boxes. Wow, 1, 2, 3, 4, 5, 6. Then you've got, like, look at 1, 2, 3. Well, that's obviously going to be 4 then to the left. Following that, and on the right here, 1 kind of 4 or double 2, 2, or so 1, 2, 2, 3, 3s. I don't know what you think, but basically 1, 4, 9, 16 should be the next one, made up in a square 4 by 4. Now, I want to remind you this, lads. They're giving away marks for questions like this. But if you don't draw that with the ruler, or you don't draw it accurately, you will be severely penalised. Okay? So make sure you get an answer like that. Okay? And that you shade in the grey tiles. Do you know, that's the 2 big things that you're asked there. Right, now that we've got that done. So, I've got it. The next part is complete the table, grey tiles. So if I'm looking at grey tiles here, 3, 4, 5, 6. So filling in here, 3, 4, 5, 6. The next one is white tiles. So I mean, we've got 2 in the first one, 2, 4, we've got 6 in the next one, we've got 3, 6, 9, 12 in the next one. Done. And then it says the total, 3 and 2 is 5, 4 and 6 is 10, 5 and 12 is 17, 6 and 12 is 26, and a note to the great Martin Halpin, you know, as he'd say, that's kiddie stuff really, like it is, you know, that's exactly what he would say. So, part C here now, moving on, find a formula in terms of n for the number of grey tiles. You've got to remember this in your log tables, lads, for an arithmetic sequence, or series. Arithmetic sequence or series. Remember the difference between the two of them. A sequence is your list, and a series is the list added up. You know, list added up. So if I have 2, 5, 8, 11, 14, that's the list. That's a sequence. That's the sequence. The series, the sum of the first 2 terms would be 7. The sum of the first 3 terms, 2 and 5 is 7 and 8 is 15. Sum of the first 4 terms, 2 and 5 is 7 is 8, 15 and 11 is 26. You get me? That's the big difference. And if you go on your log tables here, and you will find the formula for sequence of series on page number 22. Generally, all you need to remember for ordinary level is this. I think a bit of geometric comes up the odd time. It hasn't come up in years, but it can. So just be careful of that. But generally here, arithmetic sequence. So this is for your sequences, finding out your stuff, what position, this and that, and that's for your sum, adding stuff up. Okay, so as I say there, this is for your kind of sequences, your lists, a plus n minus 1 times d, and it even helps you in the log tables. Look, it tells you that a is the first term and d is the common difference. So in this particular one, a would be 2, also known as T1, and the common difference, 5 minus 2 is 3, 8 minus 5 is 3. It's a linear sequence there. If you're ever asked to prove it, if you were asked to prove that that was a linear sequence, 2, 5, 8, 11, 14, you'd show that the common difference is constant. First difference is constant, and therefore that means it's linear. If it's not, and then you prove that the second difference is constant, it'll be quadratic. Okay, so back to our question. There is enough on notes. Find a formula in terms of n for the number of grey tiles in the pattern. So we've got to look back here. Grey tiles, 3, 4, 5, 6. So that's our pattern here. 3, 4, 5, 6. I'd say I'm not a genius or a maths. Oh, I am a maths teacher. But 3, 4, 5, 6, 7, 8, 9, 10. So T1, which is A, is 3. The common difference looks like it's going up by 1 every time. So you put down your formula, A plus n minus 1. Some people are good at working these out in their head, but usually they're a bit harder. So you get A there is 3. And you just leave in, and you get your D here. Now be awful careful in this, lads. Listen to this. Now amount of people that made an absolute mulligan's mother of this here. That means n minus 1 multiplied by 1. So usually go back the way. We'll see in a second here. Sorry, the first bit is 3. 1 by n is n. 1 by minus 1 is minus 1. Don't make a mistake in that. That means 1 multiplied by this, not n minus 1 plus 1, as some people did yesterday. So tidying that up then, you get the nth term to be n, and 3 minus 1 is 2. And that should make sense there, lads. I mean, I could prove that there to you all day long. Don't be wasting time here. But Tn is equal to n plus 2. If I found the first term, T1, 1 plus 2, 3 times. There's 3. T2, 2 plus 2 is 4. 4 times, and it can keep going all day long, so that's definitely right. Use your formula. And this is the reason why, like, you know, that you can do this kind of stuff now. I could find the 10,000th pattern, or like whatever, the 25th pattern knows what we're asked. T25, you sub in 25, this is like an input-output function. Sub in 25 for n, and you get 27 tiles. Are in the 25th pattern for the grey tiles. 27 grey tiles, if you like. Next one, find the total number of grey tiles after the first 25 patterns. Well, here is after the first 2 patterns, 7. Here's after the first 3 patterns, 3 and 4 is 7 and 5 is 12. And someone in the exam yesterday actually did that, went and kept adding all the ones up. Took them about 4 hours, but they got there. When you could have just gone to your log tables and saw that the sum of the first n terms is n over 2 twice a plus n minus 1 times d. And there's your formula if you don't believe me. Right? There it is. So, we know already that for grey tiles, the first term is 3. 3 grey tiles, 4, 5, 6. And we know that the common difference is 1. So, we also know in this case, they want us to find out when n is 25. So I'm going to plug in here, S25. So set it up. I like setting it up there. Remember, it's multiplied by d. So, 25 going in where n is. 25 for n, 25 for n, 25 for n. In terms of a, 3. And in terms of d, that's 1. So, look, bang that into the calculator, lads. Bang it in there, and what do you get? I've got my marking scheme here behind the bonnet. Bang it into your calculator, and you get 375. Is the total number of grey tiles, right? 375. Find how many white tiles, lads. Be careful. White tiles. 2, 6, 12, 20. So your sequence for 2, 6, 12, 20. This is for white tiles. So as you can see here, T1, T2, T3, T4. Hopefully you will have the cop on to go and say add 4, add 6, add 8, and I mean, what are you going to do next? You're going to add 10, aren't you? Yeah, add 10, which is 30, add 12, which is 42, add 4, am I right there, add 14, which is 56, and add 16, which is 72. So add 4, add 6, add 8, add 10, add 12, add 14 and add 16 there, and you end up with 72 white tiles. Now, just an aside there, if I was asked to prove something was a quadratic sequence, 2, 6, 12, 20, 30, well, that's enough. First difference, obviously you would see that it's different, it's not constant. Plus 8, plus 10, so you'd have to go again. Second difference is constant. Second diff is constant, and therefore that means it's a quadratic. Just, it didn't come up in any of the questions I'm going to do, but the second difference is always equal to twice a. And in this case we found the second difference to be 2. So you'd find out A to be 1, and that just can be important for another bit later on where you'll get the format AN squared plus BN plus C, and now you've worked out your A. So if that happened, but it's not happening in this question. So, right, moving into parts that I was asked here earlier, how do you do this? So lads, this is an input-output function. If I put in 5 for n, I'd get 5 squared plus b by 5, wouldn't I? Yes. Wouldn't I get all that kind of stuff? Yeah? So we're told T2 is 10. Well, what you got to do here, and this is why it confuses people. First of all, you must just go to yourself, okay, well let's just plug in. Let's just plug in T2 and see what happens. Input-output function. Plug in 2, so 2 goes in, and you end up getting T2 is equal to 4 plus 2b plus c. Don't you? Yeah? Isn't that right? But this is the thing. You're told that T2 is 10. You're told that the output is 10. So we replace that fella now with 10. See, this is the key to unlocking it. And then, so that's the key to unlocking it. Now we've got to still work it out and get this. So you can write down now up here, 10 is equal to 4 plus 2b plus c. I'm going to take away 4. And I'm going to take away 4 here and we get 6. And I'm just going to rewrite it, 2b plus c is equal to 6. And that's what we're looking for. Easy peasy. That's all that happens there. And that's a really big part of unlocking a question that I was asked by another student. So, moving on here, then, this is just simultaneous equations. So, how do you do it? You can do it 7,000 different ways, lads. It's completely up to you. Completely up to you. I know for me here, I'm going to label the first equation A. I can see straight away that the number in front of the C's is the same. But when I go to add, my rule is this. Add them, does that cancel? No, it doesn't. Right, I get 3b, I get 2c, I get 10. Nothing cancels. So, I'm going to multiply the bottom equation, and I could do the top just as easily, but this is just habit, by minus 1. So, I'm going to multiply the bottom equation by minus 1. Right, so look at that again now. When I multiply that by minus 1, I'm going to get minus 1 by that gives me minus 2b, minus 1 by that gives me minus c, minus 1 by that gives me minus 6. Right, now when I go to add, now we're going to get stuff to cancel, but just be careful. Alright, when we go to add now, and we'll get these two lads cancelling, c minus c, cancel each other out. Be careful here, 1b minus 2b, so you get minus b. And this way it can just be a bit awkward if you do like this, but just went off the straight one and you get minus 2. So minus b is minus 2. That's not what b is. So you multiply by minus 1. I multiply the other side by minus 1. Don't forget to balance it out. And you get b is equal to 2. Then, that's b. You find the easiest equation you can then. Looks to me like b plus c is equal to 4. And you plug in 2 for b, and you work out what c is then. Take away 2, take away 2. That question done.